Hello and welcome back to the Raspberry Pi coding channel. This is video 5 in Humans versus AI, and in this video we're going to be introducing the ability for the player to move around the play grid. This is an important part of the machine learning cycle as well, because the ability to have an action lead to a consequence is an important part of reinforcement learning. Having a target that we're aiming for and allowing us to then have a mechanism that allows us to foresee that action and reward or penalize for that action is part of what we're going to be looking at reinforcement learning part of this video series in a few videos time. So this is a very important part of the process. As always, I have a Patreon account. If you'd like to contribute to my work, please do so, and this is the link to do it at. And if you do, you have access to the code that you can see in these videos and early access to the videos as well. Okay, cracking on then over to my IDE. So in the last video, and again I'll keep this brief as I do, we created the players on the grid, which looked a bit like this. We have a very big grid, which I've kind of inherited from a couple of videos back where I wanted to demonstrate the efficient rendering of a much bigger grid, because we now know this is a texture. And now we have random locations of different colored dots, where each of these dots represents a player. The green one is ID 1, and that represents the human player, for now anyway. So that's where we were in the last video. And if we just scroll down past or into the game app class, we'll see a few things and just remind ourselves what was happening. On draw, which is where the rendering occurs, we've got this part here, which we didn't have before the last video. And this part is rendering the players using the properties of the player class, having been instantiated in the setup section, which runs just before the game loop starts. This is the setup section, and this is the setup players method we wrote, which will set up the players so they're ready to go. And then after that, the game loop starts. And in the game loop, of course, as you know, on draw and on update are run. The other way around, of course, on update actually runs first. So within on draw, we've now got the players being rendered. Okay, so that's where we were in the last video. Now, in this one, we need to introduce the concept of being able to move a player around. For that, we're going to have to add some additional state to the player class, because we need to not just know the player's position, we need to know where the player is trying to go. Now, one option is to have a directional vector, but we're going to do it a bit differently. We're going to have a current position and a target position. There's a couple of reasons for that, but I won't go into them. But we'll just say this is what we're doing. But the first thing to mention at the top of this file is we've added another constant. That constant is player speed, because players are now able to move. And in the future, it would be nice if the player's speed can be accelerated through upgrades. So we're going to have a starting player speed. It's arbitrarily set to 4 at the moment, but it is arbitrary. Okay, as we move down, the next change is here. Okay, within the constructor of game app, we've got a new variable called keys. This is to track the keys currently being pressed by the player. It's a set, and it'll be added to and removed by arcade methods that we're going to tap into. We've made very good use of arcade throughout this series so far, making big advantages to how concise our code can be by taking what arcade gives us out of the box. So as we scroll down, we're going to see another couple of functions we're going to tap into. Okay, so we get down to here. So we're still within the arcade class here. The first thing to note is I've written a couple of placeholders, so we're just going to talk about that a minute. First off, within the onUpdate method, which so far we've left untouched because we've not been playing with any game state so far, we've now got two placeholders. One to handle the keyboard state, which is to do something with the keyboard state that we've got. Of course, that is going to be to change a property of the player, the target. And the other one is to update the player target position. So there's two things there. There's the handling of the keyboard, and there's the keys that are pressed. And then there's the actually updating of the player's position. So two separate things, and they run both in the onUpdate cycle before we draw the player, because the player might need to be moved. So we'll see what they look like, and hopefully that'll make more sense when we produce those in the next file. But now the next bit to talk about is we talk about the keys being pressed. What that means, well, these two methods are arcade methods, on key press and on key release. The hint is we're inside the game app class that's inheriting arcade window, So many of these methods will be owned by Arcade, but the little giveaway is the on underscore. So when you see that, it's likely to be an Arcade method. So on key press does what it says, and on key release does what it says. When on key press when a player presses a key, on key press is triggered. And so here what we're doing is we're saying great, in which case then let's use that method to add a key to our keys set variable that we defined further above. So the keys variable, which is a set, will have keys added and discarded as players tap the keys. Okay, so this is where our state now lives for keys. Self.keys is where we have our player interactive state. Now, talking about adding state then, so we've got a new variable for the game to store the state of the player's input, but down here the player itself, the class, has additional state variables. If you recall, we've always, well not always, but for the last couple of videos, we've had the concept of a player, or at least the last video I think, we've had the concept of the player having a position in x and y coordinates. It was self.x and self.y. This is the equivalent of that. Current underscore x and current underscore y represent the player's current position in grid space, whereas target x and target y represent the player's position where we want them to be. So they're two different things. And then we've also got a transit flag, so a Boolean flag. And what that means is when it's false, the player is stationary. When it is true, the player is moving between current and target positions. Speed is also new, which we've introduced as part of the introduction to this, with player speed being a constant. So we're now setting another new parameter. So a player now is defined by state as follows, as given here: speed, color, whether or not they're moving, and their current and target positions, as well as an ID that represents that player. Okay, so that's what we now do to define a player. Everything else inside the player class is the same, but that will change shortly. And that is it for this file. Okay, so that's what we've done. We've added further state to the player. So we've got a start and end position, a transit flag, and a speed property, which we'll be using. We are now intercepting Arcade methods to add keys or remove keys from a set, which we're going to use and act upon when we want to actually move the player. So let's move on to the next part and see what happens now. Right, so we're going from top to bottom. So I'm scrolling down. Right, so the first thing that has changed is we have lost one of our two placeholders. So on update now contains additional state changes. We've now got a loop which is going through all of the players that we have in the game. And what this loop is saying is, if this is player ID 1, which if you recall is the equivalent of saying at the moment, of saying, is this a human being playing? Then we run this code, which is to handle the keyboard input. And we'll look at this function in a minute. So for all of the players, 3, 4, 5, 6, 7, however many players we decide to set the game up with, they won't be being controlled by the keyboard, and therefore they won't be having the handle keyboard method run during every update cycle, i.e. with every frame. So nothing should be being influenced there. Okay, so handle keyboard we'll have a look at below. Here it is. There's two new methods actually, handle keyboard and set target position. But we'll look at handle keyboard first. So this is the method that is being run with every frame via the update method that Arcade is triggering for us as part of the game loop. And what it's doing is it's taking our keys set, which is a variable that, if we just go up here, you'll see because it is a variable belonging to the game app, we're passing it through here to the handle keyboard. So don't forget, keys is the state of which keys are currently depressed. Okay, so which keys are being pressed down during this frame. Takes that as an input, and then what it's doing, it first says, are we in transit or not? This makes sense. There's no point taking any action if the player's already moving, since they have to move along the grid. They need to be stationary in order for an input to work. This isn't necessarily needed forever, but whilst you're playing a game that's strict to a grid, which is a good way to start with reinforcement learning, I find, we're going to have it such that the player must be stationary for any new action to occur. And you'll see that actually works quite well. It's not as restrictive as you may think. And then what we do is we say, okay, so which key is present in the set? Is W present in the set? If it is, and it's not at the top of the grid, this is checking the target Y is less than grid size Y minus 1, i.e. it can still go further up without getting above the top. If so, then we set the target position, and we'll just go up to that function in a minute. And it's the same with S, A, and D. The same thing is happening. If that particular key object is in the set of state, so i.e. it is currently being held down, and we haven't exceeded already, the target is not in excess of a possible movement position, which means we're not going off the grid if we go any further, then set target position. So what does set target position do? Well, it goes without saying, taking the input, which in this case is incrementing in the correct direction of the keystroke. So in the case of S, key S, you're going -1 in the Y direction. In the case of key W, you're going +1 in the Y direction, pretty standard. In case of key D, we're going to the right, +1 in the X, and of course key A is -1 in the X. So we're just passing through a change in target X's position through to set target position, which just sees them as X and Y. So then it again checks if we're in transit, and basically this is where the transit flag is set. So if we're not in transit, it'll now set it as true because we are in transit, since target position is no longer equal to the current position, and then it sets the target position. So that's what it's doing. It's saying, okay, new target position is this, transit is true. Now you might be thinking, okay, great, so an intrinsic property of the player class has been changed, target X, but nothing's actually moving the dot at the moment. Current X isn't changing, nothing's changing, and you would be correct. So we've changed the property of target X to what we know it should be, which is the first stage, but now we need to actually begin to move current X, which is what we render for the player's location. We need to start that to get that to move towards target X over time, which is what we're going to look at in the next file. So if we were to run this file, which I won't do now, but if we were, we still couldn't move the player around because there's no means of doing that at the moment. What we would be doing though is we would be changing the state. We would be changing target X and target Y, but we're just not able to actually reflect that in the game itself. So now let's go on to the last file and we'll see that happen. Right, last file then. We scroll down until we get to the new stuff. Here it is. So we've handled the keyboard, which has allowed us to update the player's target position, but we're not actually doing anything with that at the moment. If I just scroll up a little bit, we'll see that draw players is based on current X and current Y. It used to be based on just player.x and player.y, if you recall, but we've now changed that to current X and current Y. Well, current X and current Y, if that's what defines the position of the circle, these are the variables that need to move in order for the player to animate along. So what we're now doing in the onUpdate method is we're looping through all the players like we are above and keeping these separate to keep it clear. And we're saying, okay, for every player, update the position, and we use something called delta time, which we're going to talk about. You'll notice this is for all players. It's not just for player one, because eventually all players need to be able to move. Right, so let's go to the update position method, which is a method belonging to the player class, and it takes delta time. Actually, before I go down to it, let me just mention delta time. Delta time is the time between, and I think I mentioned this in video 2, it's the time between frames in real terms, the actual time in seconds between frames. We're going to use delta time throughout in order that our game runs at a certain temporal frequency, as opposed to with every frame. If it runs with every frame, if your computer begins to struggle and the frame rate lowers, the entire game logic will slow down. We don't want that. We want the frame rate to go from 60 down to 40 maybe, which may affect visual prettiness, but it shouldn't affect the rate at which the game is played. And delta time is a very useful thing. It's standard in computer games to use to have a consistent time for the actual game to progress. In which case then, in order to move a player at a rate which is independent on the actual frame, bearing in mind that onUpdate runs with every frame, we need to pass through delta time to our update position function so that we can update the position of our dot, i.e. current X and current Y, the right amount based on how much time has passed. So hopefully that makes sense. So let's go and find update position. So I'm just going to scroll up so that you can see this is part of the player class. So update position is a method that updates the position of current X and current Y. That's the objective. And if we actually have a quick look down here, we can see that happening. Self current X, self current Y is being incremented. So let's talk about what this does. So this is running with every frame because it's running in the onUpdate function. So we just need to remember that. It doesn't do anything if we're not in transit, which makes sense. It's only doing something if we're in transit, and that's for efficiency's sake. We don't want to run all this code if we're not moving. Then we calculate the difference in X and the difference in Y. Now currently we can only move in one of those two directions. But we're going to assume that maybe one day we might want to be able to move diagonally. So I'm going to keep it so that distance is calculated based on the actual Euclidean distance between where we are, current X, current Y, and where we want to be, target X, target Y. And that gives us a distance measurement. Another check to make sure we are actually moving. If distance is greater than 0, then we're going to move. Now, I wrote a note here. We're scaling the movement in the X and Y direction based on delta time and the player speed. This is where they come in. Then there's an arbitrary constant, which I'm using just to moderate this so the game speed feels about right. That can be changed at will. And we're normalizing it based on tile size, I should add, which means that if we increase the size of the window, add more or lose some tiles, the game's speed won't change. So it's important that you normalize by tile size, which is why we divide by tile size. So that's basically saying how far are we going to move then in a given time increment in X direction and how far we're going to move in Y direction based on the difference between current X, target X, current Y, target Y. And that's going to be incremented by something called step X, which is calculated as part of this scaling activity. Okay, the last thing in this function is that we need to snap to the grid cell when we get close enough to it. Now we're using 0.1 here, but I would argue that should be a variable that's defined by the rate at which you're able to move. This has got to be refactored at some point in the future to avoid missing that window and overshooting the cell. It's very important that you stop at some point and snap to the grid cell, because having these two things equal and having transit set to false is what basically says you're here in this cell. If you overshoot and this isn't fired because you're going so fast that in a given frame this condition passes straight over and we're no longer able to snap, then the transit state will never go back to false. So this does require refactoring in the future. For now though, it's absolutely fine, it's quick and easy. So we're going to do it this way for the time being. So this will snap us to the grid. And that's it. So that's what we're doing. I'm going to press play so that you can see the output of this labor. So there is no AI component yet, so the other players can't move, but the logic is there such that they can if there was another input. But as only player 1 will listen to the keyboard, and I were to press W, A, S, and D now, what should happen is the onUpdate cycle will pick up the state, will pick up the key having been pressed, and we should get a step in the right direction. So I'm going to move to the right and then up. There we go, I'm just holding down the D key. And now I'm going to hold down the W key. So you can see we now have motion. If I just tap it, it'll go between cells and it'll snap to the nearest cell. So we now have a player that can move, and we now have an input, in a sense, that allows us to have an action for our machine learning model. Okay, I hope that was useful for you. There was a lot there, but if you go through the video a couple of times, hopefully it's clear. The last thing I'll say on this video is in the next video we're going to introduce the concept of having something to do, because at the moment there is nothing to do. You can just go around a grid, and that to do thing, at least in the first iteration of this game, to get us going with training the model, is going to be to collect energy, which are going to appear within the grid. So we're going to look at adding energy in video 6. Okay, that's it for today. I hope you found that useful, and I will see you in video 6. Thank you.